We present a technique to perform foveated ray tracing that combines foveated rendering with a reprojection scheme to create high-quality visualizations in modern HMDs. A frame rendered at time step t-1 is reprojected to frame t using a coarse mesh that is generated from the user's view. Artifacts arising from the reprojection and the use of the coarse mesh are resolved by finding depth and brightness discontinuities, since correcting these are critical for peripheral vision. This information is used to guide the sampling process. More samples are generated based on the user's gaze in combination with a temporal caching and merging scheme to aid image quality by reusing information from the previous frame. Our caching and merging schemes allows for reusing samples across time and space. The next sequence shows a side-by-side comparison between our renderer and a full renderer. By reducing the number of primary rays, our approach yields a speedup of almost 2 with nearly no visual artifacts in the peripheral for static scenes. The split screen view shows which samples were updated during the rendering for medium-sized foveal region configurations. For highly complex scenes like this, detecting all depth and brightness discontinuities is difficult, and full resampling would significantly decrease rendering performance. To prevent visual artifacts, our temporal blending process uses the sample's quality and the most recent update time to adapt the running estimate that combines samples temporally. This gives higher weights to new samples when updating older ones. By separating color and lighting samples, we can alter the running estimates and combine them at different rates, smoothing noisy processes like sampling ambient occlusion for the peripheral vision. We have evaluated our approach by performing user studies that compared our method to full ray tracing using an Oculus Rift DK2 equipped with an eye tracker for different common and artificial test scenes. Even for small foveal area configurations, users barely noticed any difference. This last clip shows a screen capture of our system in action. The scene is rendered at the full Oculus DK2 resolution of 1182 x 1464 with a refresh rate above 75 Hz using our foveated mode. The scene is rendered with mip-map textures and a point light source.